Today our goal is we are going to use determinants and inverse matrices to solve systems. It will actually be very, very helpful to you because we're going to learn to solve systems in 4 different ways in the weeks to come. This is the easiest, the fastest, and I'm going to show you a technology day where all I do is show you how to do every single one of the things we've done so far in the calculator. So that will make you happy as well. Let's start with 1145 times xy equals 23 negative 16. Now, if I had told you nothing, what do you think the goal of this problem is without any instructions? Good, perfect. Find x and y. Now, normally, what do you do when you have times and you want to move whatever it is? In this case, it's a matrix to the other side. In the past, what would you have done? Okay, we do not have the ability to divide by a matrix. So what we have to do is multiply by its inverse. So if we multiply both sides by the inverse of 1145, then it will get xy by itself. So we're going to take a minute and we are going to actually find the inverse of 1145. We're going to fill it in on this side, fill it in on this side, multiply it out, and make sure that what I'm telling you is 100% the truth. All right, so first, what is our inverse? 1 times 5 is 5, minus 1 times 4 is 4, so my determinant is negative 1. That's the first thing I need. Oh, it's 1. Oh, I think both of you get a point. That was like jinx. Now, once you know your determinant, you can find your inverse. So you have 1 divided by 1 is 1. And you have to adjust, remember, your first matrix into the inverse. So you switch places with A and D, change signs on B and C. Then you're going to multiply that by the original 1145. And order does matter. You multiply your inverse here first. So here you put your inverse matrix first. If I multiply this whole matrix by 1, it doesn't change anything. So when I wrote it over here, I went ahead and wrote it without the 1 divided by 1 in the front. The next thing you have to use is what we learned at the beginning of the week. How do you multiply a 2 by 2 by a 2 by 2? Good, Tate. It's going to equal a 2 by 2. So the first thing I'm going to do is I'm going to move my problem up to the top of the paper. Did anybody need more time to copy that down? Anybody? Like, I'm going to show it this one time and you're going to write it down this one time, but from here on out we're never going to write this step again. Okay? I just want you to see it and know that I'm telling you the truth. All right, so Tate's right. We're going to get a 2 by 2 out of this. So I'm going to take row 1 times column 1. 5 times 1 is 5. Negative 1 times 4 is negative 4. 5 minus 4 is 1. Then I'm going to go back and do row 1 times column 1. 5 times 1 is 5. Negative 1 times 5 is negative 5. Add them together and it's 0. Negative 4 times 1 is negative 4. 1 times 4 is 4, so negative 4 plus 4 is 0. Take your second row times your second column. Negative 4 times 1 is negative 4. 1 times 5 is 5. Negative 4 plus 5 is 1. That is called, bless you, the identity matrix, and we'll go over that in just a minute. So we now know the first 2 matrices multiplied equal 1, 0, 0, 1. And on the other part, we have a 2 by 2, again, 5, -1, -4, 1, bless you, and 2, 3, -1, 6, and we can multiply those together and bring an answer down. So let's do that next. Row 1 times column 1, 5 times 2 is 10, -1 times -1 is 1, so 10 plus 1 is 11. Then I have row 1 times column 2, 5 times 3 is 15, minus 6 is 9. Then I'm going to do the second row times both the columns. So I'm going to jump down here and say -4, 1 times 2, -1 gives me -8 minus 1 for -9. And last, I'm going to do row 2 times column 2. -4 times 3 is -12, plus 6 leaves me -6. Again, we will not, after this particular demonstration, ever multiply the next step. Look at this guy. He's a 2 by 2. This guy is a 2 by 1. So what is going to happen from this is we're going to end up with a 2 by 1. If we did it correctly, then all we'll have left is xy. But let's see if we did it correctly. What is row 1 times column 1? Well, 1 times x is x, plus 0 times y is good, because 0 times y would go away. Then you have 0 times x, which is 0, and 1 times y, which is y, so then you have y. It looks a little funny. I stole this example somewhere out of the book. I don't remember if it was an example or a problem. And that is a very quick and easy explanation of how you use it to solve a system of equations. Let me see. What if I give you the equation 2x minus 3y equals 19, and x plus 4y equals -7. 2x minus 3y equals 19, x plus 4y equals -7. We have to talk about how to get from this state into the stored matrix, like how to store everything in the matrix. We call the first matrix the coefficient matrix. So what I literally do is take the coefficients in standard form. Both of these need to be in standard form. And I'm going to pull them away from the variable they belong to and put them and store them in the matrix as if it was an Excel spreadsheet. So what is the coefficient in 2x? Good, 2. What's the coefficient in -3y, Lucas, Dylan? Right, good. What about here on x? 1. And Wes, what about here on 4y? Good. So then I'm going to multiply it by my variable matrix. What two variables do I have, and how do I know what order to put them in? Erica, what two variables do I have? Good. And Robbie, how do I know how to put them in this matrix? Yeah. And how do I know that? Well, if I double check it, what if I multiply 2 times x? What do I get? 2x. What if I multiply -3 times y? What do I get? -3y. Okay. And what if you tried to do it side to side? Then you would have this thing, 2, -3, 1, 4. Let's say Robbie said, well, Miss Walter, I think I'm going to do it this way. What would be wrong with multiplying a 2 by 2 by a 1 by 2? Why? Right. You have to have a matching columns here to rows here. So that would not be something that we would be allowed to do. Y'all write that down. I'm going to take it off of mine. Any questions? questions about how to store the first two, coefficients or variables? Does that make sense? Like you're dropping it in an Excel spreadsheet. The little cells, dropping it in there. Now, what do you think goes on this side if you were going to guess, Riley? This side, sorry. What haven't we used? Yeah, 19 and negative 7 is what we haven't used. So let's drop them here. From here forward, okay, what you're thinking is this is matrix A, this is matrix B, and this is matrix C. Okay, those are the letters that I would imagine are on each of those matrices. This is what's happening in your mind's eye. Like you've already seen how to really do it. You're going to take A inverse times A times your matrix XY. You're going to then take A inverse times C on this side. But we're not going to do all the full multiplication anymore, because what's going to happen every single time you do A inverse times A? What's it going to end up back at? 1, 0, 0, 1 times XY, which is XY. That's perfect, Harrison. So we are not going to do the actual math of A inverse times A anymore. We're just going to bring down, okay, I know that XY is all that's left over here. But I do have this multiplication that I have to do. So I do have to find A inverse. So let's do that next. A inverse needs a determinant. So 2 times 4 is 8. And 8 minus negative 3 is 11. So over here I have negative 1 over 11. And this is my A inverse that I'm working on. Just kind of out of the way so that I can use it in a minute. Negative 1 over 11. Where did I get that 11? Britta, where did I get that 11? Is it? Oh, I changed the problem. Yes, good job. Make sure you sign those things. All these people who catch bonus points. I don't see very many signatures on that one blue. Now, exchange places with A and D. Change signs on C and D. And then when you bring it down here, I would probably leave 1/11 out there just like that. Do you have any idea why I would leave 1/11 out there instead of going ahead and multiplying by it? It's going to make a bunch of ugly fractions. So let's put the 1/11 as the scalar multiplication on the end. All right, so we have four 3 times 19 and negative 7. So my answer from a 2 by 2 times a 2 by 1 is a 2 by 1. So make sure, because that's review, but it's still pretty new. We just learned it this week. Make sure you're okay with why the answer is a 2 by 1. So I'm going to do 4 times 19. And that is 76, and 3 times negative 20. I'm going to go back and do times column. Negative 1 times 19 is negative 19. 2 times negative 7 is negative 7. So then 76 minus 21 gives me 55. So I really have 1/11 times 55 in this position. And then in the lower position, I have negative 19 minus 7, which is negative 26. I don't know, did I just do something wrong? Oh, yep. Another point today. Good job. So 2 times negative 7 is negative 14. So then we have negative 33. So what is 1/11 times negative 33? Good. So it boils down to x is 5 and y is negative 3. Why was that one just a pain in the behind? Because this 1/11 makes it a funky fraction had we put it in here. So because order of operations, you can wait till the end and multiply by the ugly fraction if you like. So 5 and negative 3 are your x and your y. Now, how could I check this? Like, I'm not sure. This is way new, and I'm not sure what to do with it. Harrison?
Well, you could plug it into the first system.
All right, the first system was 2x minus 3y equals 19. So let's say that I'm going to try Harrison's trick. Since I'm new at this and I want to see if it's right. What is 10 plus 9? For sure, it is 19. Now, do you have to do a check step? No. But it would be helpful for you to gain confidence and say, hey, I know that I have this right, this 5, negative 3. This is one of your homework problems. Let's work on it together. The most important thing to get the problem right is at the very beginning, set it up and get each thing in the right position. And believe it or not, when I show you how to do this in a calculator, this will be very, very fast for you when we get to systems. So let's start with our coefficient matrix, and I would like for Karaya to tell me what goes in my coefficient matrix.
2, 7, 5, 1, negative 1.
Good. So 2 from the x goes here. The negative 7 from the negative 7y goes here. The negative 1 from the negative 1x goes here. And the 5 from 5y goes here. Multiply it by the variable matrix equals, what goes in our answer matrix here? Selena? Perfect. That guy's 10 minus 7, so I have 1/3 times A and D trade places, B and C change signs, and then I just bring down my negative 6/3. So 2 times 5 was 10, minus negative 1 times negative 7, 7, gave me a determinant of 3. I rewrote this matrix where I changed A and D places and just changed the sign on B and C, and then I brought down my constant matrix. I think here I would do a similar thing as last time. I would leave the 1/3 till I was done. 5 times negative 6 is negative 30. Negative 30 plus 21, negative 9. That was that row times that column. Then I'm going to do this row times that column. Negative 6 plus 6 is 0. What's my final answer there, Rachel? Perfect. And if you wanted to check it, you could take that negative 3, 0, plug it into one or the other, make sure it worked so you had confidence in it. Where do you think the most arithmetic mistakes are made? After you get it set it up and you feel confident in setting it up, where do you think the next most common arithmetic mistake is? Try to anticipate what could go wrong. What do you think it might be? How about you, Hunter? What do you think? Multiplying for the determinant is probably the next thing. And then remember Ashby's question at the beginning, how in the world do you get it set up right on the inside? That's the third thing. That people either forget to switch A and D, or they switch the wrong ones, or they don't switch the signs on B and C. So it's a matter of being super careful, not necessarily hard. You guys have been doing multiplication facts since what, 3rd grade? It's not the multiplication. It is you're trying to do so many things with it. On my hand, it's always the multiplication because I am terrible at doing it in my head. All right, we are on page 214, 215. So if you want to copy those, they're all at kind of the top of page 215. So if you want to use your cell phone and take a picture of someone's, you'll get a couple of them done, I think. And then we have a technology day where I will show you some shortcuts on the calculator, and a lot of you will already know them. Mm-hmm.